All right. So yeah, 4 to 5, and today is October the 2nd. Um, so yeah, we're a little ahead. It goes a little ahead, a little behind. So this weekend, of course, tutorial 4 and assignment 2 are due, and then I will have released assignment 3. I don't think assignment 3 is super like big, I guess. But with 5 assignments, we can kind of like narrow in on certain things that lessons that I want you guys to learn. And it is based off the assignment 2 code. So when you make assignment 3, you're going to create at least one new class and then change some existing classes. But I'll give you like the code if you want to use it, or you can use your own. Either of those is fine. And then the midterm. So next week we'll talk a little more about the midterm. I think for you guys, yeah, that's it. So yeah, that's everything on the calendars. In the immediate future, any questions? Okay, so last class we were talking about encapsulation. We were taking, our objects that were already private, had a bunch of private member variables and functions and things like that. And we were talking about, well, we're going to make them more private, but we're also going to talk about the consequences of that. So one of the things we were talking about is composition. And that applies to, well, if we look at, oh yeah, 1 second. So I think my OpenStack instance is full and not responding. So I will have to fix that. But not right now. So there are instructions. It might happen to you because VS Code is terrible that way. It just, for some reason, will, I don't know what it's trying to do, but some of the extensions, the C extension, just cache a whole bunch of information, like more, I mean, so much information. It defies the laws of physics, how these small programs could actually contain that much information. But there are instructions on Brightspace for how to fix it should you run into this problem. So I'll have to do that later. But for now, we're going to run off my local machine with Ubuntu, with the Windows subsystem for Linux. So last class, we were looking at student and address. And right, so I have an address that is contained in my student class, which means that in terms of memory, I have something that looks like this. I have a student, and they have like a name and a number, and maybe a little bit of stuff, memory reserved for that. And then also along with it is an address, right? So technically these are stored as structs, right? The functions are off somewhere else. The compiler just keeps track of which functions belong to which class. But in terms of memory allocation, they're just structs. They just have this information. So a student has enough bytes to store a name and a number and everything the address stores. Right? So the address is stored right alongside the member variables of the student. And so yeah, what that means is that, where was I going with this? Yes. So despite the fact that they're side by side, the address is private. Right? So we've been talking a lot about encapsulating our objects, making things as private as possible. So what does that mean now when student and address want to work together? Well, first of all, in my student class, I really don't want to be storing a bunch of address stuff, right? Because I'm really concerned with student stuff. I'm concerned with grades, assignments, which class I'm taking, whether I'm going to graduate. The address stuff is sort of, I don't really want to overcomplicate my student class. So what I do is I choose this address class because it knows how to do all that address stuff. Then I don't have to worry about it. I just delegate. And that's a lot of object-oriented programming is like delegating to the correct subsystem. The consequence, of course, is that, well, I want to use the address, I want to use the information, but I don't have direct access, so I have to kind of stick with the access that the address class gives me. Even though this is contained inside my student and private, I have to respect its privacy. So, but that's also a good thing. I don't have to worry about how the address class is implemented. If I want to print my student, I print all the student specific information, and then I say, oh yeah, also I have an address, but I'm going to let my address class handle that function. That also means we also had a problem with initialization, right? So I wanted to initialize the member variables of my address class, but of course they're private. I don't have direct access. So I have to somehow use the constructor. The problem is the constructor, as soon as I make my student, or I try to make a student, the address is made first, right? So first the address constructor is called, and then the student constructor is called. So even if I wanted to supply arguments to my address constructor, which I do, I can't do that in my student constructor. So we saw that there was a special syntax we could use, the member initializer syntax, which, the syntax is after the argument list of my constructor, colon, followed by the name of the variable, followed by all the arguments I want to give it, city, province. And this gets run before my student constructor. So as soon as my home address is made, I pass in these values, these parameters, and then it can properly initialize itself. And so yeah, that's how we sort of respect the privacy of the home address. We only initialize it using the constructor, and we use this special syntax in order to grab it before it's constructed. So that's roughly where we left off last class. Questions so far? Okay. One thing that was mentioned, I think, can't quite remember. I get this class confused with the other one. But we can use this member initializer syntax with all of our parameters, right? So I can do name. Here, let's bring it down here where it's a little more visible. So name, number, major program. What is this, NPM? And GPA, right? So GPA is a float. The rest of these are strings. Oops, this should be a G. But as it turns out, well, strings have constructors, but even our primitives have constructors. So technically everything has a constructor. And at the end of the day, I can make a student constructor that has an empty body, right? In here, I'm still printing this out, but I don't really need to. The job of initializing all the member variables is already done before the student constructor is even called. And this works just fine. Yeah, we can go in there and yeah, so Stu is at 123 Main Street, Ottawa. Great. Yeah, I think we talked about this. Again, I'm getting you guys in the other class mixed up. But yeah, I think I'm pretty sure we got that far. So member initializer syntax, I use that. And the other thing, again, I can't remember if I mentioned this or not, but let's say that I had an address. Why did it do that? So I no longer have a default constructor for my address class, right? I took out one of the default arguments. Now, if I ever make an address, I need at least one argument, right? So whereas before, my student class would have compiled if I didn't do this. Now, if I take this out, right? Before I would have got an address with just the default values, but now I have no default constructor for my address class, which means that if I take it out of here, no default constructor exists for class address. The constructor gets called before the student constructor. So even if I tried to do something in here, Like it would be too late, right? So if I do not have a default constructor, then I absolutely have to use member initializer syntax. I have no choice. If that's statically allocated, right? Any statically allocated member variable, oh, even here it's complaining. Every statically allocated member variable must be initialized. But yeah, this brings us to this other problem. Here I have a copy constructor. If I had used the default copy constructor, I wouldn't have a problem, but here I am facing the same problem that I faced up here. I have a home address that I need to initialize, but I do not have a default constructor. So what I'm going to use is the copy constructor of my home address class, right? So you'll notice that, well, address doesn't have a copy constructor, or at least we didn't write one, but you get one for free. You get the default one, and the default one does the job it's supposed to, which is it does a byte for byte copy. We'll explore that in more detail in a moment, but for now it's enough that in my copy constructor, well, that's just another constructor, so I still have to make sure my home address is initialized before the constructor body. All right. Questions? Yeah. Again, just because the let's sort of look at this messy thing here. So when I make a new student, right, so let's say I make a new student. So enough memory is allocated for my student class. And then what happens is it looks at the member variables. So it says name, number, address. So student needs those three things, and it wants those to be created before my constructor, right? Because maybe I need these things. Maybe it's not an address, but maybe it's a file object. And so in my constructor, I want to open a file and load my student information, so I need that file to be created first. So member variables are created before the object. And that includes the address class. So the first thing that happens is, well, some of this is reserved for the address. So the constructor is called, and this is populated with whatever. But it is calling the constructor. And so if I don't use this member initializer syntax, it's going to look for the default constructor, right? How much time does it save? Yeah, it saves, so I guess we saw, like this would have been how we did it in assignment 1, right? I said home address equals address, and then number, street, city, province. How much time does that save? Like a blink of an, like not even a blink of an eye. But like over, if I had to make 10,000 students or 40,000 students, then I am saving actual time, right? So it all adds up. So yeah. And yeah, memory, again, well, just allocating this student and filling it up with memory and then copying that memory somewhere else. Like I'm just doing a bunch of stuff that I don't need to do. And that's okay in other languages and actually is pretty much the rule in other languages. But in C++, we try to avoid that. Right? C++ is a race car, which means it's kind of hard to handle and it can be a little bit dangerous, but it has that performance when we need it. And if I'm just going to the grocery store, I'm probably going to use Python, right? I'm going to drive my little Python car because I don't need all that performance to go to the grocery store. But if I'm racing, then I want C++. So we care about this stuff in C++. Yeah, we care about these little details, I guess. I don't know. Does that answer your question? Okay. All right, other questions? Okay. All right. So the other question is, I guess, what happens if, well, this is, right? So we talked about copy constructors a little bit. This is what my student class looks like now. And if I call the copy constructor, well, what happens is exactly what we started talking about is well, I need this many bytes for a student, right? So the compiler, wherever I am making this copy, will allocate that much memory. And then what it does is, if I just use the default copy constructor, it just does a byte for byte copy. So it just takes every value it finds here and just copies it over. That's what your default copy constructor basically does. So now I have a copy, a perfect copy, and the address of each of them is separate, which is great. Probably that's the behavior I want. So each student is a copy, but now they have their own address, right? They're roommates maybe, but one can move out. But maybe I want to save on the amount of stack space. So maybe instead of an address object, I'm just going to store an address pointer. And then when I make my new student, I'm going to make a new address on the heap. Okay, so let's look at that scenario and then talk about all the consequences of what happens. And, okay, so I'm going to make a student Stu. Stu presently address is statically allocated. So instead of an address, I'm going to store a pointer to an address. It means I'm going to have to change a bunch of syntax. So here I return an address by reference. So this should be an address object, which means I have to dereference it. Yeah, that's all fine. Over here, of course, oh, well, home address is now a pointer. So giving all these values to a pointer doesn't make any sense. So, well, I can go back to the old-fashioned way of allocating it. Not quite like this. But now I'm going to use the new keyword. So now this means I'm going to make a new address. It's going to go on the heap. And yeah, but it's initialized, right? So home address is now a pointer. It gets initialized to whatever garbage, who cares? But in my constructor, I can assign it to this new address. All right, and then where am I? 2, right? Okay, so Stu, yeah, he's on 123 Main Street, Ottawa. Perfect. So I made and I printed a student. The compiler's complaining about something. Oh, I'm rather surprised that that compiled. Oh, sorry. All right, I did it in the wrong one. Let's try that one more time. So yeah, this should be. Yeah, there's no getter here. Okay. Okay. And probably down here, yeah. So I have a move function. We'll see how that works. So I also, we'll dive into that in a minute. For now, I'm just going to change everything so that it uses a pointer instead of an object. And then I'm going to make my student and print them. Okay, great. So that works fine. Of course, now I have a memory leak, right? Because I did not delete Stu, and it called new, but I never called delete. So let's delete Stu and make sure this still works. So far, let's use valgrind. And oh, I still have a memory leak, right? So 104 bytes in one block. Okay, so what happened is I put my address on the heap, but nowhere in my student class did I delete it. So here I said new address. And if I have new inside my class, probably somewhere I want to delete it. This is dynamic memory, right? It's on the heap. And then when I deleted my student, I just deleted this thing, but I did not delete this thing. So let's go into destructure of my student and delete that. Make sure that our memory is all cleaned up. Okay, perfect. Make. Okay, still works. Stu prints out, no problems whatsoever, and no memory leaks. Okay, so I've cleaned up my memory. Great. So I have a student, same sort of functionality, except now my address is on the heap. That's probably a little more convenient. It's dynamic memory now, so that means I have to manage it. So I have to delete it somewhere. The most logical place, if I had created it in the constructor, is I delete it in the destructor, and that makes perfect sense. But questions so far? Okay, well, let's make a copy of Stu. So I'm going to make a student Joe. I'm going to use this initializer syntax. So this will call the copy constructor of my student class. Then I'm going to give Joe a name and print him out. And then print out Stu, and we'll start there. I just want to add a little more formatting. Lack of spaces. I don't like the look of it. Okay. So I made a copy of Stu. Joe, of course, gets Stu's address, right, which we would expect, and then we changed Joe's name to Joe, and then we printed them both out. So they're both here in Ottawa. They're roommates. But let's have Joe move to Montreal, and let's take a look at this move to function. It says home address set city city. So I actually have a set city function in my address class. Okay. And then, so we're going to move Joe to Montreal, and then we're going to print them both out. And so what's going to happen? What's going to happen? So here they're both all 123 Main Street, Ottawa. And then Joe gets moved to Montreal. So Joe's in Montreal on the same street. And so is Stu. So I made a copy that called the copy constructor. Do I have a copy constructor? I do have a copy constructor. In my copy constructor, I just did the basics. I did just this byte for byte copy, right? I just used the assignment. This is exactly what the default copy constructor would do. If I hadn't written it, it would do exactly this. And what happened was, well, I made my new student. I called him Joe, and it made a byte for byte copy, which means that this address, this pointer to a street address, which is also a memory address, it just got a copy of the memory address of Stu's address, right? So now Stu and Joe are both pointing at the same address in memory. And you may think, well, that's like inconvenient, but not really a huge problem. Well, yes and no, because I didn't delete Stu here. So let's delete Stu. And I get a segmentation fault, right? So what happened was I have dynamic memory. I cleaned it up. And so Joe is statically allocated, which means that Joe gets deleted automatically. Stu is dynamically allocated, which means I delete Stu when I call delete, the destructor gets called. So when I called Stu's destructor, well, Stu got destroyed, and also the address got destroyed. And then when I called Joe's destructor, well, it tried to delete this address, and then I got a seg fault because it no longer belongs to me. I gave it back to the operating system already. All right, so dynamic memory is a little bit tricky. If you don't do a deep copy, then you have to worry about all of these kinds of conditions. Like if I have two students pointing to the same address, who should delete that address, right? It can only be done by one of them. So basically, probably this is not the thing that I want to have happen. What I really want to have happen is this. I want to make, on the heap, I want to make a byte for byte copy of the address and then point this pointer to my new memory address. And then I have two separate students. They each have their own address. It's a copy, so they start out as roommates. But then if one moves away, I no longer have that problem. Okay, so this is what's called a deep copy, right? So if I go back to my student class, I have my copy constructor, and this is where the problem originated, is that I just copied this pointer into this pointer. So I just copied a memory address. But what I really want to do is a deep copy. So deep copy, if I'm doing a deep copy, you should see new in there somewhere. And yeah, so I'm going to use the copy constructor. I'm going to take stu.home address and dereference it. That will return an address object, and I will make a copy of that address object on the heap and assign the address to home address, right? So this makes that copy. And so now if we try and run this, so here I made a copy. They're roommates in Ottawa. Joe moves to Montreal, so we see Joe is in Montreal, but Stu is still in Ottawa. And then they're both destroyed at the end, and there were no seg faults, but let's double check and make sure also no memory leaks, right? So I managed my memory correctly. So yeah, that is what's called a deep copy, and assignment 3 is going to be, making deep copies. Of course, this is a very simple deep copy, right? What if address also had dynamic memory? Then I have to sort of consider what to do there. What if I had a whole list of things with dynamic memory, right? So now I have a bunch of other considerations. Now it's not so simple. But yeah, questions? Okay. All right, and that, yeah, so this is stuff that we already looked at. Incidentally, like before we leave this, so here I initialized home address, but before we needed member initializer syntax, well, I can still use it, right? We can use it for all of these, but I can also use it for this pointer. Say home address. So a pointer has a constructor, and it's a copy constructor, so I can make a copy of another pointer. And well, new will return a pointer. So number, street, city, province. Right, so I can use this member initializer syntax even on a pointer. And this will work just fine. Yeah. And they both get they're both initialized, and they both, everything works. All right. All right, so if we have an object with a pointer to another object, and we just use the default constructor, we get this. We get two students who are both pointed to the same address in memory. And this is called a shallow copy. And occasionally, this might be actually what you want. But for the most part, probably what you want is to make a deep copy. where I make an entirely new address, and now my new student points to a new address. And then when I delete it, of course, each of them is responsible for deleting their own address, and I don't have this problem where two students delete the same address. Okay. But I mean, this brings us to sort of a deeper discussion as well. When I made a new address, I had a dynamically allocated piece of memory in my student class. Well, you'll notice that I needed to make a destructor, right? Before that, I could have just used the default constructor and it would have worked fine. But now that I have dynamic memory, now that I have new in the constructor, I need a destructor, right? In order to destroy it. And actually, well, that we saw, I also need a copy constructor. If I'm making copies of students and they have dynamic memory, then I have to write my own copy constructor so that it does it correctly. And there's a third thing, the assignment operator. Actually, let's take a look at that. So let's say before I delete Stu, I do this. I'm going to take Joe and I'm going to, again, make a copy of Stu. This time, Joe's already been created and already exists in memory, but here we're going to use the assignment operator. The assignment operator, like the copy constructor, is just a byte for byte copy, which means that, well, which means the following. So again, I'm making a copy of Joe. I'm going to maybe I forgot to change Joe's name, so maybe Joe is going to have the same name as Stu. And then Joe's going to move to Montreal, and then I'm going to print them both. So you can see down here, I made a copy of Stu. So I made a copy of Stu into Joe, but now, of course, they're both named Stu, and now they both moved to Montreal. So this assignment operator did this exact same thing as my copy constructor. I guess it's over here, which is this. When I assigned Stu to Joe, it did, the assignment operator and the copy constructor are basically sort of, they do the same thing, but the copy constructor does it when its object is created, and an assignment operator does it at any time. So I ended up in this situation again. And so I ended up with the same set of problems, right? So if I delete Stu now, and then try and print Joe, let's say, well, Joe is going to try and print his address, and he's going to get a seg fault. Okay, so we can rewrite the assignment operator, and that brings us to kind of this idea of the rule of three, which is, the assignment operator runs into the same problem as my copy constructor if I have dynamic memory, and that is doing a shallow copy. So I want to do a deep copy, but you don't get that for free, you have to write it. So what happens is if I have dynamic memory, right, if I figure out that I need a destructor, then I probably need a copy constructor, and I probably need an assignment operator, because I have dynamic memory now. So if I need one of these three things, I probably need them all. So that's the rule of three. The rule of five is similar. So we are not going to get into move constructors and assignment operators, but a move constructor does the exact opposite of a copy constructor, is that I want to make a copy of this student, let's say, but I know that this student is going to be destroyed, right? So rather than making a deep copy, which means that, I'm just making a copy and then I'm deleting this address, well, that's sort of a waste. I'm just going to steal this address from this student. I'm going to assign this to null, and then that student will get destroyed, no problem. And I just have the original address. And so move operators and move assignment operators and move copy constructors steal resources, which is sometimes that's what you want to do. Okay, questions? All right, let's talk about const. So basically, if you've seen any C++ code, you may have seen this little guy littered everywhere. right? So what do we use it for? Well, there's a bunch of different things, but the main thing is protection. Two main things. I'm going to make it so the compiler catches errors for me, right? Again, it's the same as the access modifiers. I can just program really, really carefully, but if I make things private, then the compiler catches when I do something I shouldn't be doing. Const does the same thing. It gives us this extra layer of protection at compile time, but it also, there are certain, and I was trying to think of an example last class, but I came up flat. But there are examples where your compiler can, if it knows something is const, it can optimize a little bit better, right? Which means you're going to get faster code the more you apply const. And it's not just like an academic thing. As sometimes there are things that are just academic that really don't work very well in the real world. In the real world, you really do put const everywhere you can, right? That is sort of that is a real thing that really works to improve your code. So yeah, there are, we can make constant objects, we can make constant member functions, we can make constant data members. But before we do that, now that we're introducing const, we're going to see a whole new class of errors. These are going to be very long errors for the most part, but when they made C++, they referred to things as L values and R values. And so what they're talking about is basically an assignment operation. So this is an assignment operation, and so the left-hand side of an assignment is getting a new value. And so an L value is something that can be the left-hand side of an assignment, which means it's something that can be changed. It's like a variable, right? A variable that's not a constant is an L value. On the right-hand side is, well, in this case, it's an R value. You can have an L value on the right-hand side of an assignment, but an R value can only be on the right-hand side of an assignment. And so some examples would be, well, like I can't do something like this, right? 5 equals 4. This is an R value. It's just a value. I cannot assign it a different value. Also an expression, right? So an expression returns a value. So I cannot write something like this that doesn't make any sense, right? So A plus B is just going to return whatever A plus B returns, some value, and that's going to be an R value. Also, if I return by value, that's an R value, right? I can, typically what happens is I make, a new student equals get student. So if I assign it, what happens is it gets copied into Stu, and maybe Stu is an L value, right? So that's fine, you can do that. But the thing that is actually returned by this is an R value. I cannot actually make changes to this. So yeah, those are some examples of R values and L values, and you will see them in some compiler stuff. But questions so far? Okay, so let's break some stuff. And yeah, we can basically, using the const keyword, we can turn any L value into an R value, which is what we're going to do. Okay, so, well, these are not consts, but we'll get there. So I have an int and a string name, and we're just going to run this first, and then we'll do some fancier stuff. P3. Okay, so obviously I can read them, and I can also change them. I can say number equals 23. Okay, so that's fine. This little thing is a lie, but that's okay. We're going to make it true. So we're going to apply the const keyword here. Now these become constants. So that has a couple of consequences. One, of course, if it's a constant, I cannot change its value. It's now an R value. It cannot be on the left-hand side of an assignment operation. I don't see any red squigglies here, so let's try that out. And lo and behold, I can still print these things. So these are now read-only variables, right? I can't change them, but I can read them. I can write them to the screen. I can do a bunch of stuff with them, as we'll see. I can do this. Well, I can't do this, right? We've already seen, so once I've declared this string, it's fixed, right? So technically, if I do this, I cannot reassign it, which means this is just a blank string. If I try to do that with an int, it actually won't even let me do that. So string has its own default constructor, so it can be constructed, but an int, I have to assign it a value. So this needs an initializer. So any constant variable I have has to be initialized right away. Right? If it's an object, of course, it's going to be initialized right away if it has a default constructor. If it doesn't, you will also get that error. Okay. All right. Question so far is pretty easy. So let's get into the date class. So this is a date class similar to what you've seen on your assignment. Oh yeah, and I've spoiled the surprise. Okay, so one thing you'll know about, yeah, I gotta fix this too. We'll come back to all this and talk about why these may or may not be good choices, but for now, I have a date class, and I did something a little different. I made these public just so that we can demonstrate what happens. So I'm going to make a date, and I'm going to, print it out. I don't really need these anymore. I'm going to make a date. I'm going to print it out. I'm going to change the date, and it doesn't like that. Redefinition. Yes. No, that should be fine. Oh yeah, I do have 2 prints. All right, never mind. I have 3 prints actually. That's the problem. Okay, so I made a date, October 2nd. So today is the 2nd day of the month, and then I changed that to 20. So today is the 20th day of the month. But let's say now that I want to make this a const object. Okay, so we can see the compiler right away is not happy. Expression must be a modifiable L value. So when I made this date constant, what I did was I made these 3 member variables constant. Right, so now I cannot change the value of these 3 member variables. So I can get rid of this. It appears that I can still read them. I can still access them and print them to the screen. And indeed I can. So if I make my classes constant, my objects constant, then that makes the member variables constant, and I can no longer access them. All right, questions? Okay. What about this question? d1.print. Oh. Says object has type qualifiers that are not compatible with the member function print. So what is the problem? Well, the problem is in this print function, maybe I try to change one of these member variables, right? So the compiler is like, whoa, you can't do that. I don't trust you, right? I don't know what's in that function. Maybe it's, maybe I haven't linked the code yet or whatever. So, yeah, all right, well, we'll continue with this. So how do I fix this? Well, how I fix this is that I'm going to go into my date, and I'm going to look at a new way to apply this const keyword. I'm going to tack it on to the end of my function. So now what I'm doing is I'm making a promise to the compiler. I'm saying, in this function, I promise not to change these member variables. And so here I'm going to add the const keyword. So it has to be in both the declaration and the implementation. Of course, our problems are not over yet. So we saw earlier how we can, of course, read these things. They're read-only. And I didn't write it to any of them, but I did call this function. And in this function, I didn't make any promises not to change these member variables, right? So maybe in this function, I changed the day variable. And I made a promise in my print function that I wouldn't do that. So if I call another function in here, that function has to make that same promise, that get month name also has to be const. I'm going to promise that, where is it? Right here. I promise that in this function that I call, I do not change day, month, or year. And indeed, I don't. I just return these variables. If I try to, the compiler is going to say, no, you can't do that, right? This is a const function. In a const function, all the member variables are considered R values, considered constant. But now that I've done that, you can see I can print, or at least the squiggly has gone away. And yeah, so I printed here. Right. Is the chat delayed, or do I just miss it? I don't know. I seem to always get these questions like long after I've asked them. It might be me. Maybe I'm not paying attention. All right. So yeah, that's how I would use this. This is now a const object. I can call print on it because I promised in the print that I would not call or would not change any of the values. If I wanted to, what about this now? And actually, let's do just to make it a little bit nicer. Oops. Okay, so printing the date, it did print from a non-const object. I called a const function. That's perfectly fine. We're allowed to do that. So const functions have an advantage in that I can call it on a const object or a non-const object. And yeah. Oh, well, but we haven't talked about function overloading, but in this language, as in many other languages, I can't do this. Whoops. I can't make two functions that look exactly the same, right? And by look exactly the same, the return value doesn't matter, but same name, same number of arguments, and in this case, the same const qualifier. I'm trying to overload a function, and the compiler will not be happy with me, right? So cannot be overloaded with this function, cannot be overloaded with this function, because they look exactly the same as far as the compiler is concerned. But actually, if I do this, this is a different function signature, right? So one is const, one is not, and the compiler can tell these apart. So I can make a const version and a non-const version of my print function. And oops. So if I go back here, so this is the non-const print. And you can see it called the non-const print on the non-const variable. Can we add more helper methods in the assignment, like getters to be specific? Yep, you can add getters if you use them. That's totally fine. Yes, you can definitely add helper functions. In fact, I would basically encourage it if, as long as it makes sense. You can do, as long as you present, I ask for some public functions, as long as you give those to me, you can make whatever other functions you want. don't make getters that you don't use, I guess, is the only rule, right? So we are trying to enforce, it's not like Java where we just make getters and setters by default. We are trying to protect our objects in C++. So if I need a getter, you should make a getter. If you don't need a getter, you shouldn't make a getter. All right. So I have a non-const version of my print, and that got called. And I have a const version of my print that did not get called. Well, here, yeah. So the const version gets called on a const object. The non-const version gets called on the non-const object. Yep. Yeah, and sorry, what was the last part? I mean, not. It could happen, of course, but not in our assignments, no. And yeah, for the most part, I think that's pretty accurate. But you'll see, like the fact that we can overload these print functions means that even if we had to do some modification, we could do it. We could just say that, but you just can't use that if it's a const. Yeah. All right. Other questions? Yeah. Date.age, yeah. Oh yeah, we're gonna get to that. You're gonna there's so many places you can put const, it's crazy. I think you can even put it here syntactically. I don't even know what this means, but doesn't seem to throw an error. So I don't know. But yeah, we are gonna get to that. So the question he asked is, can you do this? And yes. In fact, you probably should do this. We will talk about why you should do this and what the consequences are. Of course, it depends if this is an input variable or an output variable or an input-output variable. For now, yeah, so which function should we make const? Well, every one that we can where it makes sense, right? So there are some easy ones, like this less than function. Of course, in my less than function, I do not change any values. I just compare them, right? So I'm just reading all of the values, year, month, and day, and comparing them. So less than would be a good candidate for this const. Getters can also be consts sometimes, right? So what is I mean, when can't it be const? Well, here I'm returning by value, which means that get year is taking the year, it's making a copy of it, and it's returning that copy. So if I did something like this, and I tried to return by reference, now it's not making a copy of year. Now it's actually returning a reference to year. So it's returning the variable itself. Yeah, so let me just update this so we can properly track the errors. So this is a const function that is returning year by reference. And we can see here that the compiler does not like that because I promised that I would not change year, but now I'm handing this variable to somebody else, right? Because I'm actually handing the variable itself and not a copy. So somebody else can grab it and then make changes to it. So this violates this const agreement. If I pass by value, it's fine. But the other thing I can do is pass by const reference. And right, so now I'm saying, yeah, I'm returning this by reference, but it's a constant, so you cannot make changes to it. I mean, of all the things we talked about, I would just worry about that one the least. Just return by value, and then all your problems are solved. But just in case you wanted to play with that, you could. All right, questions? Okay. Let's see, did I forget anything? 5 o'clock. All right, so the principle of least privilege says the object you create don't need to be modified. You can make them constant, right? So if I have a date, New Year's Day, it makes sense to make it constant. I don't want somebody changing it to February 2nd or something like that, because now this variable is completely corrupted. So this guarantees the integrity of your objects and guards against other people corrupting them, helps the compiler catch errors, helps the compiler optimize. Sometimes it's difficult to see, as you'll see when you try and apply this to your next assignment. You're going to make something const, and then it's going to make another. You're going to have to make another thing const, and you're going to have to make another thing const. And somewhere down the line, you're like, no, I can't make this const because I need this function that actually changes something. So in some cases, it's easy to see that a function should be made const. Other cases, not so much. This is putting a const modifier at the end of a member function. So we talked about all of the possibilities there. We can have two versions of a member function, const and non-const. So yeah, principle of least privilege, any function that you can get away with making const, you should. Because then it can be used in more cases. It can be used on a const object or a non-const object, right? So print, I may want to print const objects or non-const objects, so that should be a const function. Certain getters, of course, if you return by value, it's fine. And for the most part, we're just returning by value. All of these simple Boolean functions that test some condition and return true or false, those can all be const. Constant data members. So we're getting to parameters at the end. So yeah, it's coming. Constant data member is a data member that can never be modified, even in the constructor. So if I look at P5, yeah, I might speed up a little bit. So if you have questions, please just ask. But I have a student. Right, so I make 3 students, and then I'm going to print them out. Okay, perfect. So Stu and Amy are both in basket weaving, and Cindy, well, Cindy got the default values because we didn't give her any arguments. Well, when you become a student at Carleton and probably other universities, you get a student number, and that's your student number forever. Right? If you leave and come back 20 years later, it's still your student number. So if I have a student class, maybe I want to do this. Maybe I want to say, well, the student number, once they assign it, it should stay const forever. Okay, so, well, what we're going to do is look out for these little red squigglies. And of course, what happened is that, well, the same as when we tried to initialize address, by the time we get here, it's too late, right? This has already been initialized with the default constructor for the string class. And so when I try to assign it a value here, I'm really trying to reassign it a value. And it's const, so I'm not allowed to do that. And yeah, this is one of those things where you get these nice little error messages, right? Because it's basically trying to convert it to something that works. So if I have a const member variable, I cannot initialize it in the constructor. But what I can do is use this member initializer syntax, right? I'm going to catch this number, this string object before the constructor is called and say, hey, when you call the constructor, use this as an argument, right? Use this string that I'm passing in. And then I can make my students. Of course, so this all works. Cindy here, I mean, it's a problem because she got a default value. And so this doesn't make a lot of sense because now I cannot actually give Cindy a number. So if I'm doing this, probably I do not want to give a default value to anything that is going to be const. If I do, you should be aware of the consequences. Like you're going to get the default value and it'll be that value forever. All right. The other thing is, so yeah, Cindy, it was nice knowing you, but you don't have a student number, so you cannot be a part of this. Cindy, let's say you saw the assignment operator once, it just makes a copy. Copy constructor is fine, because copy constructor, I can catch that student number before the constructor is called and pass it an argument, but this is an assignment operator. So Stu already exists, and now I'm trying to make a copy of Amy by copying all of those values into Stu, but I'm not allowed to copy over Stu's student number, right? So as soon as I make a constant member variable, well, what does it say here? It says, this function cannot be referenced. It is a deleted function, declared implicitly. So we used to have, right? And if I go to, well, let's reverse that. And lo and behold, so I get an assignment operator by default, and it works fine. But if I make one of my member variables const, your assignment operator is going to get deleted, the function. So you can write another one, but basically the compiler is saying, I'm trying to make a copy of Amy into Stu, but I have this const variable that I cannot copy into. So, so you're on your own. If you can figure it out, you can make an assignment operator function, but you lose the default one. All right, questions? Okay, yeah, I think that's constant parameters. So we are going to get there, sweet. Yeah. So consider the data members you create. If they will never be modified, make them constant. I will actually walk that back. Generally speaking, if I want my student number to stay the same, I can make a private and then just never change it. That's probably a better approach, right? This is problematic, making a constant. In this class, I will never ask you to do that, probably. Can we do Cindy equals Amy? If Cindy already exists, you cannot do that, right? You mean if I made a default Cindy, I run into the same problem. So no assignment operator whatsoever if I have a constant member. Well, not whatsoever. I can still write one, and then I have to decide what to do in that case. But whatever I do, I'm stuck with whatever the whatever value was first assigned to that member variable. I'm stuck with it. Okay. Constant parameters. So yeah, that's the two places where we saw member initializer syntax, and where we absolutely needed it was with these constant parameters. So constant data members. So if I have a constant data member, I have to use this member initializer syntax. The other thing is if it contains another class, and that other class does not have a default constructor, then I have to call this member initializer syntax to assign it values. Okay, so constant parameters. All right, so again, I have a student class. Now I have this move to function, and I'm going to move to a new address. And, you know, like a good software engineer, I pass the address by reference. Inside this move to function, I use the assignment operator, right? In this case, I have statically allocated the home address. So I'm going to make a student Stu, a student Joe, print them both out, and then we're going to move Stu to his new place. Okay, so Stu is in, well, some default street, 123 street. And Joe also gets the default address. They'll both get default address, but now I want to make a new address, and I want to move Stu to that address, and then we're going to print them again. Guess I don't even really need Joe here. So initially Stu was no fixed address. We moved him to Montreal, so now he's in Montreal, Quebec. Okay. Yeah, let's get rid of Joe. Don't really need Joe. And that's fine. So what happens, maybe I want to shorten this. So what we can do sometimes in C++, and what I often do is, well, I'm making a temporary address variable, and I don't really want it to hang around long. So I'm just gonna make it right here, and then it's really just scoped into that function call. Okay. So let's try and make that. And it turns out I can make these temporary anonymous local variables, but they are R values. I cannot make changes to them, right? Which means that, well, when I pass it into my student, I passed it by reference, and this is not a constant function. I'm not making any promises not to modify it. And it's an R value, so I definitely need to make the compiler happy and promise not to modify it. So when I pass an object by reference, and this is the address, I don't really need to change it. So I'm just going to promise the compiler that I will not change this parameter. Okay, and then make, and yeah, Stu gets moved to Montreal, Quebec, and I managed to pass in like just a super temporary address object just to pass that information in. Okay, so when I'm passing parameters, the same as when I'm making functions, if I can make that parameter const, I should, because now I have more use cases available to me. All right, questions? Okay, there's one other thing I wanted to, I think that might be it. Oh yeah, strings. So there is one other thing. When do we add the const keyword in the parameters field, and when do we add it outside? Yeah, that's a good question. So, so here I have a get name that is const, and this means that in this get name function, I promise that I'm not changing any of these variables. And if I change some of those variables, the compiler is going to catch me. When I declare this address const, I'm promising that I'm not going to change. Let's just give it a name. I promise that I'm not going to change this variable, right? I can make changes to these because I have not done this. So this const means that I'm not changing these variables. This const means I'm not changing this variable, even though I'm passing it by reference. And you can do this syntactically, it works, right? So what did I do here? I'm passing by value. So I'm making a copy of the address that I'm passing in, and then I'm saying, don't modify it. This is unnecessary. So if I'm passing by value, you can put const, but it's really functionally not going to make a difference. When you pass by reference, that's where const comes in handy. All right, other questions? Okay, so one more thing before we go. What about these strings? These are actually objects. Why aren't we passing by reference? So I said pass by value or pass by const reference. What happens if I do this? Well, first of all, compiler's not happy. So let's take this part away. So now my student, I'm passing in the first argument by reference. Yes, of course. Okay, so that's good. No complaints from the compiler. So my student class is okay. When I get here, it's complaining. No instance of constructor matches the argument list. So if you remember from C, any string literal that I declare in my program is a immutable string. Goes on the data segment, I cannot modify it. And so what happens when I pass this in and it's a string that I pass by value? Well, the compiler is going to be nice. It's going to convert this character array into a string. And then I can modify that string because it's going to make a copy of this character array. When I pass it by reference, I'm actually passing, the compiler is still going to make a copy, but it's going to be pointing to this string literal. So this is a constant. And I cannot pass a constant by reference. I have to pass it by const reference. So as far as parameters go, anytime you pass an object, primitives you don't have to worry about, right? Primitives, you can make copies all day long. It doesn't cost you more than 8 bytes, generally speaking. But for strings, you should now be doing this. Don't pass by value, pass by constant string reference, and that solves this problem, right? So I'm still getting this immutable string passed to my student, but I promise I'm not going to try to modify it. And of course, any parameter, this has to match. Any parameter that you pass in, such as this address, if you can make it const, make it const, right? So TAs, some of the tests will catch this stuff. Some of the tutorials will catch this stuff, but the things that aren't caught, the TAs are going to look for, right? So this is, if you don't do this, you're going to lose marks. And yeah. For assignment 3, yeah, not assignment 2. Yeah, the next assignment. Tutorial 4 is this weekend? No. You'll see if it passes. Tutorials nobody looks at. So just if it passes the test, it passes the test. Okay. Yeah, so that's constant parameters. String literals are a little bit problematic. So yeah, we have to do this. All right, so we have all these rules, and of course, now we're going to break them, right? C++. So we have put all these protections on, and now we're going to say, well, we said our object should be introverted. Well, we're introverted unless somebody is your friend, and then if you're a friend, you share everything. So sometimes an object can share private things with a friend if they want. So it does violate data encapsulation. So this is a way to break the rules, but of course it's C++, so they let you break the rules, but also sometimes you need to break the rules. We're going to see actually situations where we need to use friendship. So if I'm a class, I can grant friendship to a global function, another class, a member function of another class. And what happens is that if I grant friendship, you have access to all of my member variables and member functions, regardless of the access modifiers, right? So you get all private and protected variables and functions you have access to. Fortunately, it can only be given. Like I can't demand friendship from another object. I can just say, I'm a friend of this object. And so, I can share my private stuff with that object. And it has to be done explicitly. So I do not get like, if I grant friendship, if A says that B is a friend of A, that does not make, this is symmetric. If B is a friend to A, that does not mean A is a friend to B necessarily. It has to be explicitly done. And if A is a friend to B and B is a friend to C, that does not make A a friend to C, right? So I do not get that transitive quality either. It always has to be explicit. So yeah, where do we want to use it? Sometimes you might have classes that work closely together. I'm going to say you don't bother doing that, but we will need it for overloaded operators. We're going to see why. All right, and let's jump into it. See how far we get before 5 minutes left. So again, I have my student and I have my address and I have spoilers. Okay, so I have a student. My student contains a address. It's a pointer that's not really relevant in this case. In my main function, I'm going to make a, we're going to move our students. So let's skip the part where we do that check. So we have this move to function where I want to take my current address and change the city and the province. And I don't have any setters in my address class. And I want to change these private member variables. So sort of what I want to have happen is something like this. Home address, city equals city, and home address province equals province. Okay, and you can see, of course, the compiler is saying, well, you don't have access to these, so you can't do that. But this is what I want to do. I don't want to make setters because maybe somebody else will take advantage of the fact that my address has setters. I just want to make this just so that I can do it alone. So in my address class, I'm going to say friend class student. So the same way that I forward reference, well, we haven't seen forward referencing classes yet, but we will. But the same way I forward reference a function, right? I say a function exists, but I don't give the details. Here I'm telling the compiler there is a class called student, and it is a friend of mine. So when you see that student, please cut them some slack. And you can see here that our problems went away at this point. So we go here. We print out our students and we have them both move, one to Vancouver, one to Montreal. I believe they're both homeless at the current time. Yeah, so when I first make Stu and Joe, they're both, well, actually, Stu has an address. Joe is homeless. Stu moves from Moncton to Vancouver. And Joe moves to Montreal. He's still homeless, but at least he's in a nice city. And we did that by directly accessing the private member variables of address because we were a friend of address. All right, questions? Okay, so that is, I granted friendship from my class to another class. We can also do that with a global function. So here I have a global function where, and down here, I want to do this. I want to access, it's a student now, and I want to access, well, home address is, well, first of all, home address is a pointer, so let's fix that. But home address is private to student, so it's complaining about this, and then province is private to home address. So let's address the first one. 1 minute. I'm going to say right. So I'm going to void. So there is a function called where, and that function is a friend of mine. So you saw now that the home address is no longer highlighted. So this function can access the private member variable home address. But we still don't get this, right? Even though address is a friend of student and student is a friend of this function, that does not mean province is a friend of this function. So I actually have to, the same thing I did here, I have to declare in my address And then maybe that'll work, or maybe, let's try that. Okay, well, it compiled. There are problems that can come up, but we will discuss them next class. You will notice that, or maybe you did notice that I kind of forward referenced address here, and even student for some reason. I probably don't need this, but there are problems that can arise. But yeah, so that is French. We will pick up with this. You guys, are we done this week? You're the Monday class. Yeah, okay. So yeah, I'll see you guys next week.